All right, weather weenies, let's talk about why this happened in Connecticut with all the flooding. Crazy thing is instead of storm line, there was like an endless line of pop-up storms that just appeared from New York City but didn't show up on the radar before the city. Let's talk about why that happened. Here is yesterday's radar playing through very, very quickly, and you can see that hardest hit area just being relentlessly affected. Also, this is the satellite imagery for the same day, so you can go ahead and zoom in and you see just that cumulus right there, really like the heavy convective stuff, but otherwise just this precipitation that's just relentless. Weather Prediction Center did highlight this area as a place that was going to potentially see some heavy rains. I mean, we're getting into the red, so maybe like 4 or 5 inches possibly in some places. Really talking about 1 to 3 most areas. Localized to scattered flash flooding is likely. Sunday morning's forecast radar reflectivity showed there was going to be a lot of precipitation in that area, but not the training storms that we ended up getting. And the HRRR forecast model, QPF, quantitative precipitation forecasts, we're showing amounts as high as, close to 6 inches in some locations. Some of these locations saw more than double that. If I go back and read the forecast discussion for yesterday morning for the Albany office, it says some embedded thunderstorms could develop across the mid-Hudson Valley, northwest Connecticut shortly after daybreak, which could contain heavy downpours. We'll have to watch for possible training of heavier rain cores, which could produce some isolated scattered flash flooding across portions of the southeast Catskills, mid-Hudson Valley, and northwest Connecticut. So there were inklings, there were some ideas that this could potentially happen, but the location was slightly off, and the magnitude was way off. I can't stress enough how incredibly difficult it is to forecast these types of events, but I know that that doesn't make this any better for those who are stuck in places or have potentially lost people they care about. These are a few screenshots from the National Weather Service broken down by county, showing the places that have received the most rain. Some observations are even higher than this. These are just locations where they were able to officially measure what's going on, but radar indicated rain totals in some of these places is going 13, 15, even 16 inches of rain that fell in some of these places. And the kicker is how fast it happened, as Dr. Craig here talks about. This is including 3.5 inches in just 1 hour in some of those locations, and that is catastrophic. Looking back, kind of doing a post-mortem on this, what went wrong? And what we have is this high combination of very, very high dew points and an incredible amount of moisture available in the atmosphere with just the right dynamics aloft to allow that moist, humid, hot air to rise up and condense and just put an unprecedented amount of water down onto the ground. So here we see these really high forecast dew points just off of the coast, and they're just there and unrelenting. That's just very, very humid air, which means there's more water to condense out of that and fall as rain. And as for the dynamics, they're on this exit side of this 500 millibar trough right here. Let me tell you what that means. That exit side of these big troughs are where we always look to for like thunderstorms when we're forecasting for storm chasing and want to see any of that, because what you get on that eastern side of the trough is divergence aloft. So the air is flowing along, but it ends up going like this. And when it does that, you create an area of low pressure here. And in order to fill that in, it has to bring air from down below to fill that up in. And so you have this rising motion, which if you have this really warm, humid air below it, causes that condensation, causes all that moisture to turn into water drops. And if you have just the right setup, which is super hard to forecast, and you have the dynamics aloft that match the moisture down below, you kind of create this engine of non-stop rain production. A lot of people are describing what happened as like a 1 in 200 year flood, 1 in 500 year flood, 1 in 1,000 year flood based upon the data in those individual locations. When you have a 1 in 1,000 year flood, what that basically means is there's a 0.1% chance of that magnitude of flood happening in any given year. A 1 in 200 year flood has a 0.5% chance of happening on any given year. So what happened is very rare, and hopefully you understand a little bit better now why this happened and why it occurred.